Welcome, everyone, to this lesson on decomposition and abstraction. This lesson is part of Pearson Edexcel International GCSE Computer Science. Today, we will learn important computational thinking skills used by programmers to solve problems effectively. We will explore real-life examples, programming concepts, abstraction, decomposition, inputs and outputs, and much more. Let's begin. By the end of this lesson, you should be able to understand computational thinking. You will explain decomposition and abstraction clearly. You will learn how to break large problems into smaller subproblems. You will also identify inputs, outputs, processing, and initialization. Finally, you will understand how abstraction is used to model real-world situations. Let's explore these concepts step by step. Computational thinking is a logical method used to solve problems. It involves understanding problems carefully and creating step-by-step solutions. Computer scientists use computational thinking when designing programs and algorithms. Key skills include decomposition, abstraction, algorithm design, and logical reasoning. These skills help programmers create efficient and reliable software. Computational thinking is used in many areas of technology. Software developers use it to build applications and websites. It is also used in artificial intelligence and robotics. Banks use computational thinking in ATM systems and online banking. Game developers and mobile app creators also depend on these skills. Computational thinking helps programmers solve complex problems efficiently. Decomposition means breaking a large problem into smaller subproblems. Smaller tasks are easier to understand and solve. Each subproblem can be tested separately. Different teams can also work on different parts at the same time. Decomposition makes software development more organized and manageable. Let's look at a real-life example of decomposition. Imagine planning a birthday party. The main problem is organizing the entire event. This can be broken into smaller tasks, such as venue booking, food ordering, guest invitations, decorations, and cake arrangements. Each smaller task becomes easier to complete. This is decomposition in action. Large websites are also divided into smaller sections. For example, a website may contain a login system, payment system, product pages, and search features. Different developers can work on different modules. This improves teamwork and speeds up development. Decomposition helps large systems become easier to build and maintain. Here we can see decomposition in a computer game example. To create a tic-tac-toe game, programmers must solve several smaller problems. They need to create the game grid, store player moves, detect winners, detect draws, and program computer moves. Breaking the project into parts makes coding easier and more organized. Decomposition provides many advantages. It makes debugging easier because errors can be found in smaller sections. Development becomes faster and teamwork improves. Code can also be reused in other programs. Large systems become simpler and easier to manage. This is why decomposition is widely used in software engineering.